Hello everyone. Today I am going to introduce you to Langflow, a tool that makes it much easier for developing AI agents. As we know, universities deal with massive amounts of data, student records, course details, examination related data, and many more. Managing all this manually or through traditional ERP systems can be very time consuming. This is where AI agents can make a big difference. Imagine a student asking, "What is my next exam?" or "What is the fee due date?" An AI agent can answer that question instantly without going through all the entire ERP. AI agents can automate routine tasks. It can answer questions based on university policies or course syllabus or other internal documents. And as we know, it is available 24/7. So AI agents have an important role. It can transform a university ERP from just a record keeping system to a smart system that enhances the overall campus experience. So, what is Langflow? Before explaining what is Langflow, let us briefly touch upon LangChain. LangChain is a very powerful Python library for building AI agents, but it is coding intensive. Only a good Python developer only can use LangChain effectively. Sometimes you just want to experiment quickly, visualize your workflow, or share it with your development team. In that case, Langflow is very useful. Langflow is a drag and drop interface for LangChain, something like a Figma, but for AI agent development. You drag blocks like inputs, LLM, prompts, output, etc. onto a canvas and connect them visually, and then your solution is ready. Within minutes you have an AI agent or a chatbot up and running. That's really cool, right? Otherwise it takes few days or a few weeks to develop such applications. Two ways you can do. One is you can log into cloud version of Langflow, or you can install it on your laptop. First, let us build a simple chatbot which has three blocks: input, LLM, output. Okay, now this is the Langflow. So you come here and create a new project, a new flow, and we'll start with a blank flow. So this is the empty canvas. You go to input output, take one input and one output, then you search for OpenAI. We need one LLM block, so you got LLM block, connect here, keep it here. Then you connect the chat input to the LLM block, connect the LLM block to the chat output. Now here you have to specify the OpenAPI key. So what we have to do is generally go here, create a new variable and save the key, and then onwards we can use that key. Right now I have already saved my API key in something called OpenAI key, so I am using that. Okay, so my chatbot is ready now. So if I give something input as a prompt, it comes here and my chatbot LLM answers and the answer comes here. So to test this one, you can see, go to the playground and say, okay, give some details about Bangalore. Congratulations, you have done the first chatbot. As expected, the chatbot shows a lot of information about Bangalore. Okay, we have seen a simple chatbot how it is working. Now we will make it a little more smarter using a technique called a RAG. RAG stands for Retrieval Augmented Generation. It's very simple. The concept is we give a document to the LLM and then we ask the questions to LLM. LLM will answer based on the document given to it. So it will not go to the internet and get the information. It will answer based on the document that we shared with the LLM. So in that way we can share our confidential or private data or any such documents with LLM and we can ask. So LLM will answer based on the given content. So this is how the RAG works. We can divide into two parts. Part 1, you upload the document, and big documents you split it into chunks or blocks, and you convert that each block into an array of numbers which computer can understand. And finally these embeddings are stored into a vector database which is designed to handle and quickly search through this kind of data. Now in part 2 is about answering questions. When you ask a question, the system also converts your question into embeddings. It then searches the vector database to find the closest matching block from your document, and it returns the best answers using those matches to give you a response that is accurate and based only on your data. So that is the principle. In short, we can say part 1 prepares the data and part 2 retrieves the right answers whenever you ask a question. So part 1 is done generally once, or whenever there is some change in the document only you have to do part 1. Part 2 is any time you can ask questions. So to make the flow a little more clear, so upload the documents, PDF document or Word document, then the system cut it into multiple blocks and the system transforms into something called embeddings and save it in a vector database. So this is part 1. It's a kind of one-time activity. After that, any time when the user asks a question, the LLM take the question and match it with the content of the vector database and gives the answer. Okay, now let us see the advanced version of the chatbot which answers the questions based on the documents that we give. So these 4 blocks represent the part 1 which I mentioned earlier. There is a file block here, there is a split text block, there is an AstraDB block and add neuron and an API OpenAI embeddings block. So these 4 blocks are selected from here. You search here, you will get the block. For example, file, if I give, I can see the file block, drag it here, drag it something like this, and then you click here, then you choose the file you want to select. So you can select and upload. Once if you say select file, that gets uploaded. So similarly, bring the split text component and AstraDB component and these embedding components. In OpenAI embedding components, you have to give the API key. Then connect it like this. This output goes here, this goes here, this and this are connected. Now AstraDB is a vector database which you have to create an account. So you have to go to AstraDB site, this is their site, you have to log in and then you have to create a DB and this token, here you can generate a token. This token is important. That token you have to give here AstraDB application token. Then it automatically pulls that DB name which you created there. That DB name will appear here. After that you have to create a collection Collection is very important. You have to create your collection and connect it. Now our part 1 is almost ready, and to test that one I can just click this output last one, this run. So it is running now and checking this flow. If everything is fine, it will say successful. If there is any error, it will report the error. So flow is built successfully. So this is the part 1. So with that, when I clicked here, what it has done is it has taken that document, converted into small blocks and vectorized and saved in the Astra database. So all this is done. This is a one-time activity. Now I have few other blocks here. It's basically very simple. What it does is it takes one input from user and it is connected to this AstraDB again. Then it is also connected to a prompt block, and prompt block is connected to our LLM. So LLM always needs a prompt. So prompt comes like this, and LLM also needs some context where to search. So that context comes from this AstraDB. AstraDB, some parsing is done and given as a context to the LLM. Now what happens is when I enter a prompt, the prompt comes here, prompt comes like this, and LLM looks into the data, Astra database, and gives the answer. That is what happens. So to test that flow, I can show you like this. Go to the playground and I can write, okay, when is the internship starting? This is the document that I have given is about an internship in the university. So I can just ask, when is the internship starting? It takes few seconds to answer. It is still processing, and the answer is here. The internship is starting on October 13, 2025. So now onwards, any question that you ask, it will refer to the document and answer. So it is very useful that way. Now once if you do this much, what you can do is find, that means our flow, everything is correct. We can create one API endpoint. So if you click this one, you get an API endpoint. This is called API endpoint. So you can call from Postman, you can call this one. So that's what I'm going to do. In Postman, I will give a post request with this payload. So payload has output type, input type, and the prompt. What is the document is about is the prompt in this example. And it needs one token or an API key to do that. So you got to go here and create an API key and take this one, this link, and comes to Postman. So I'll go to Postman. So you can see here, I have pasted that link here, and API key which I generated there, I put it here, and in the body I put the same thing, input value, when is the internship starting, or we can say what is this document about, what is this document about. And if you give this one, send this post request, yeah, you can see this document is an internship offer letter from KAIST University for a position within the CDIRP team. It outlines etc. etc. So this API now we can call from anywhere, and if you give your prompt, you will get the answer. Okay, so that is the end of this demo. So Langflow makes it simple to design AI agents visually. It's perfect for web developers who want to quickly integrate AI without rewriting backend logic from scratch. You can go from idea to prototype to API and to production in a matter of hours. That means an agent can be developed in 1 or 2 hours. If you already know LangChain, Langflow will feel like a visual extension. If you don't, Langflow is the fastest way to get started with AI agents. Thank you.